All right, guys, this is lesson number 2 on the periodic table. You had a bit of an introduction to it in the last lesson, so you should have kind of an idea of what it is, but we're going to look a little bit more at how it's laid out. Now, I mentioned in the lesson write-up that you should be, if you're watching the video, you should still be going through the slideshow on your own as well, because I have put into it a number of links to some videos for you to watch. So make sure that you check out the slideshow as well and check out the videos. Most of them are anywhere from 1 to 4 minutes long, so they're not very long. Okay. All right. So here we go. So if we're going to start off with some general information about the periodic table. First thing, columns in the periodic table go up and down, and we refer to those as either groups or family. Now, groups are going to be based on the number that you're going to find at the top of your periodic table. Families are going to be names, and we're going to talk a little bit about some of those families a little bit later on in this lesson. Rows are what are called periods. All right. So a column we call a group or a family. A row we call a period. Basic layout to the periodic table. We have already talked about this a bit in class, actually, but this huge section here of the periodic table are what we call metals, and you can see it in the legend up at the top. So everything that's purple here is a metal. Along here are what are called the metalloids that we are going to pretty much ignore because they are just too much of a pain to deal with. And then up here are what are called the nonmetals, and there's one more over here. All right. Now, looking at some properties of the metals versus the nonmetals. Again, we're going to kind of ignore the metalloids for the most part. Metals tend to be shiny. They tend to be malleable or ductile. These are some of the properties, the chemical and physical properties that we've talked about previously. All right. So malleable or ductile, you can draw them into wires or you can hammer them into sheets. Their conductivity, they are generally able to conduct electricity with some exceptions. And then reactivity with acid, they tend to react with acids. Nonmetals, on the other hand, they tend to be more dull. They're brittle, so if you hit them with a hammer, they're going to break. They do not conduct electricity, and they do not react with acids. Metalloids are kind of in the middle. They behave a little bit like metals and a little bit like nonmetals. They are complicated, and we don't want to deal with them, so we won't. So some examples. Metals you're pretty familiar with, probably. Iron, copper, steel, bronze, aluminum, gold, silver, mercury. These are all metals. And again, looking back at some of the properties, you see shiny, malleable or ductile. You can think of something like aluminum foil. Lead, for example, you can flatten out into sheets. Conduct electricity. So things like copper we find in wires. Gold is also commonly found in wires. Aluminum is also found in wires. And then reactivity with acids. Acid etching is a fairly common practice, but not something you probably be very familiar with. Non-metals, on the other hand, you can see they're dull colored. Examples are carbon, sulfur. You can see there's the end of a hammer here that's being used to hit it. So they obviously are not able to be hammered into sheets. They just kind of shatter into pieces. Okay. We're going to spend the rest of this looking at the major families in the periodic table. And again, a reminder that the families are columns. We refer to columns as either groups or families. We'll call them groups when we're talking about the numbers at the top. So if you look at your periodic table, you should see numbers 1, 2, 3, 4, all, et cetera, going all the way across. And if we're talking about them as families, we're going to refer to them by a particular name. So we're going to look at some of those families right now. So the first are what are called the alkali metals. And you can see they're found on the left-hand side in that first column. Notice that hydrogen at the top is not included in this because, again, hydrogen is one of the non-metals that we find over here. It just happens to be at the top of this column. And the reason it's there is because it actually has the same number of electrons in the outside orbital as these do. We're not going to get into that in any kind of great detail. That you'll learn a little bit about next year. All right. So again, the first column here is called the alkali metals. Here are some examples from that. They typically are very reactive. And if you were, for example, to put any of these elements, any of these metals into water, they would violently react. And as you actually go down the periodic table, you would find they actually get even more and more violent. Now, there is a video that you can watch here at the bottom. I've got a link to it and a couple of other ones on the next page as well. And you may notice as we go through here that I've decided to add in some very cheesy little jokes. So there's one there for you if you want to read it. All right, so here are some videos that you can check out. This is the one that was at the bottom of that screen. It's a fairly accurate portrayal of what alkali metals do when they're in water. This is a Brainiac video, and it is not entirely realistic. They took a few liberties with it, but it's still an entertaining watch. And then this is an old video on the disposal of sodium. The next group, or column, or family, is the alkaline earth metals. So you can see that is the second column here. They are also reactive, but they are not as reactive as the alkali metals, and they do not react in water. All right. Again, a video for you to watch on your own, and another cheesy joke for you. The next is this big group in the middle, and these are what are called the transition metals. And they tend to be fairly unreactive. And if you look at your periodic table, you'll see things like copper, iron, silver, gold, and that sort of thing. All right. Common property for all of those is they are quite good conductors of electricity. And again, another video for you to watch. And again, another cheesy joke for you. The next column, the next family, are what are called the halogens. You can see that's the second last column here on the right. They are very reactive, but they are nonmetals. All right. So the first column were the alkali metals. They are very reactive. The second column were the alkaline earth metals that are reactive as well. And then this second last column are the reactive nonmetals. All right. Again, another video for you. And then we have the noble gases. The last column here are what are called the noble gases. Now, if you were looking at patterns, you would think, okay, the first couple of these were really reactive. This one was really reactive. I'll bet this one is. You'd be wrong, actually. These are actually very, very non-reactive. They are actually called noble gases for exactly that reason, because they do not react. They are also referred to as the inert gases, because again, they don't react. All right. Again, there's a video for you to watch. And again, another cheesy joke. The final group is this chunk that is found down here in the bottom. All right, these are called the rare earth elements. Now, what you may not realize about the way the periodic table is laid out is that this section is actually supposed to be right here. All right. The reason the periodic table is normally going to be found looking like this, where you've got this big chunk here, and then there's these couple of rows that just seem to be just kind of pulled off to the bottom, is because if they were actually where they were supposed to be, this would be too wide for the screen. It would be too wide for a piece of paper. So what they've actually done is these two rows are actually supposed to squeeze in right here. All right, so it should be this element, and then this, and then it goes all the way across, and then it goes back up to here and keeps going. And then you get to the end, and you go to the next row, and it goes here, and then it goes down to this one and goes across, and then goes back to here, and then finishes off. All right, so if you actually look at the numbers on those elements, you will see that these elements here actually fit in right here. Okay? All right, so the properties, they are called rare earth elements because, shock and surprise, they are rare. Some of them are radioactive, so you'll see, for example, you'll find uranium in there, which is a fairly commonly known one. They are very typically used in a lot of modern technology. The element project that you guys will be doing at the end of this unit, so next week, some of you may or may not choose to look at a rare earth element when you do that element project, and you might learn a little bit where in modern technology it's used. A couple of more videos for you to watch, and then to finish it off, a couple of more cheesy jokes for you, and we're done.